so on the remainder and factor theorem, first of all, the essential question is how can you use the remainder and factor theorem to determine if a factor is a root of a polynomial? A root means a solution or an answer to the polynomial. So we want to know how we can determine if this is the answer to the polynomial. Okay, so using synthetic division. So let me show you what synthetic division means, and that was on a earlier thing, maybe last week. But if you divide by x minus 3, that means you take the opposite number and you put it in a box. So you put the 3 here in a box, and then you write down your coefficients or your numbers in front. So your numbers in front are 2, -5, and -1. So we write down 2, -5, and -1. We're going to bring the first number down. So you want to bring down the 2. Okay? As you bring down the 2 below the line, you're going to multiply by the number in the box. And the number in the box is the 3. So we're going to say 2 times 3 is 6. We put that in the next open spot. The next open spot is right below the -5. Then we're going to add -5 plus 6 is 1. And we get the 1 down there below the line. Then we're going to multiply. 1 times 3 is 3. And then we're going to add -1 plus 3 is 2. That last number there is our remainder. So our remainder is 2. That's what I'm going to write. I'm going to say R, that's our remainder. Our remainder equals 2 in that one. So that's the remainder when it is divided by x minus 3. That's how you do it with synthetic division. Synthetic division means if you're saying x minus 3, you put a 3 in the box. If it was x plus 3, you would put a -3 in the box. And then you write your numbers in order. 2, -5, -1. Bring the first number down. You multiply, add, multiply, add, multiply, add until you get to the end. That last number is your remainder. Okay? That's using synthetic division. That's one way. An easier way, I think, is using the remainder theorem. So the remainder theorem says, what is the remainder when 2x squared minus 5x minus 1 is divided by x minus 3? So basically what we're just doing, the number that goes in the box is a 3, right? So that's the number that we would plug in for x. So we're going to find f of 3. Basically, we're going to plug 3 in everywhere we see an x. So everywhere we see an x, we're going to plug in the number 3. So now we have plugged in 3. So it's 2 times 3 squared minus 5 times 3 minus 1. So we're going to say 2 times 3 squared. Well, that's 9 and 2, so that's 18. Minus 5 times 3 is 15 minus 1. So that is 18 minus 15 minus 1, which gives you 2. So your remainder is 2, just like it was in synthetic division. So I've given you 2 ways to get the same answer. And I think just plugging the number in for x is actually a little bit easier, right, to get the remainder than using synthetic division. That's why they call it the remainder theorem. So synthetic division, when you're dividing polynomials, it's easier to do synthetic division than it is long division. But if you want to know if something has a remainder or not, it's actually easier to plug in the number than to do the synthetic division. So you're able to see that the remainder is 2. All right? So we want to use the remainder theorem to do these examples that we have down below. So I'm going to erase that, and then we're going to go down to these example numbers of them there. So disregard if you see like an E, but you should have 4 problems. So the first one is p to the 4th plus 5p to the 3rd minus 11p squared minus 25p plus 29. And we want to use the remainder theorem to divide by p plus 6. So what number should we be plugging in for p here? If it says divide by p plus 6. -6, yes. So everywhere we see P, we're going to plug in -6. We're going to see what it equals. Now, that will give us our remainder. So every time we plug that number in for P, we will then get our remainder. So we can go to our calculator and we can say, we can move it down. We can go to our calculator and we could say, in parentheses, we always want to put in parentheses, -6 to the 4th plus 5 times -6 to the 3rd minus 11 times -6 squared minus 25 times -6 plus 29. And we've typed all that in the calculator and we get our remainder. So our remainder there was -1. So we're able to plug it into the calculator. We're able to get a remainder of -1. Okay. If your remainder is something other than 0, then it means that it's not a factor, which means like it doesn't divide into it evenly. So that means you had a remainder other than 0. It means it's not going to be a factor. So we're going to do this with the other ones as well. So let's look at B. Now, B looks a little harder. So what number do we plug in? It's a little harder to figure out. Well, if you're not sure what number to plug in, set this equal to 0. 3x minus 1 equals 0. Okay? So let's solve for x. So the first thing you would want to do is add 1. So 3x equals 1. And then the next thing that you would want to do is divide by 3. So x is equal to 1/3. So 1/3 is the number that I want to plug in for x. So everywhere I see an x, I want to plug in 1/3. So 3 parentheses 1/3 to the 3rd minus 4 parentheses 1/3 squared minus 17 parentheses 1/3 and then plus 6. And I want to see what that equals. So that's how I'm going to use the remainder theorem to do that. So I'm going to take my calculator again, and I'll move it over here. And I'm going to say 3 parentheses 1/3 to the 3rd power minus 4 parentheses 1/3 to the 2nd power. Oops, I got it. Let me clear that. Okay, minus 17 parentheses 1/3 and then plus 6. Now, what you get here is a remainder of 0 when you do that. So your remainder in B is 0. So if your remainder is 0, that tells you that that actually is a factor. So I'm giving you something that's getting ready to come up in this next part. So we get a remainder that is 0. That means 3x minus 1 goes into this polynomial, into this equation evenly, gives you a remainder 0. Remember, like when you said, like, how many times does 8 go into 40? 5. And there's a remainder of 0. That means 8 goes into 40 evenly. But if I said, how many times does 8 go into 41? You would say 5, but there's a remainder of 1. It's the same thing here. We're saying, does this go into that polynomial evenly to give you a remainder of 0 or not? So in C, what number would we plug in? Positive 2. So we're going to say 2 to the 4th power minus 8 times 2 to the third power plus 10 times 2 to the second power plus 2 times 2 and then plus 4. And that's going to give us our remainder. So I'm going to let you plug that in and try. And then here, in this last one on here, you get 2v minus 3. We have to set that equal to 0 to decide what we're going to plug in. So we're going to add 3. So 2v equals 3, and we're going to divide by 2. So v equals 3 halves. So 3 halves is the number I'm going to plug in D. So 4 parentheses 3 halves to the third plus 6 parentheses 3 halves to the second minus 8 parentheses 3 halves. And then we're going to say minus 12 is equal to. You're going to find your remainder. So I want you to try to find your remainder in C and D. So you need to practice plugging those in, making sure you can go to that power effectively. 0. So the answer for C, when you plug all that in, is 0. And then the answer for D, when you plug that in, is 3. Would be your answer. Yep. So F of 3 halves. When you plug 3 halves in, you get 3. Okay? So those are your answers as you go through. That's called the remainder theorem. So basically, whatever number you're dividing by, take the opposite of it and plug it in. If you have something where you're not sure what you're dividing by, set it equal to 0. That's the number that you're going to plug in. Just like you're doing here. Y minus 2 equals 0. That means y equals 2. That's why we plug in 2. P plus 6 equals 0. That means P equals negative 6. So you plug in negative 6. So you always set it equal to 0 to decide what number am I going to plug in. So now we're going to go to the factor theorem. The theorem says if we calculate this, the remainder basically, and it equals 0, if we plug in that number and it equals 0, then that means the remainder is 0, and that means that this must be a factor. So like in B, it means 3x minus 1 is a factor of that polynomial. In C, it means y minus 2 is a factor of that polynomial. Okay? A factor is the same thing as a root. It means like if you say y minus 2 is a factor in C, that's the same thing as saying 2 is a solution or a root. It's where it crosses the x-axis. It's the same thing as saying it's an answer. So we're going to determine which ones of these two are factors. And the way we determine that is which one of these two give us a remainder of 0. Okay? So in A, we're going to be plugging in, remember, x plus 1 equals 0, so x equals negative 1. So we're going to be plugging in negative 1. And in B, x plus 3 equals 0, so x equals negative 3. So we're going to be plugging these into that equation. So negative 1 to the third plus 4 times negative 1 squared plus negative 1 minus 6. And we're going to see what we get. And then here we're going to plug negative 3 into that same equation. Negative 3 to the third plus 4 times negative 3 squared plus negative 3 and then minus 6. So you want to plug those in. It's not a long equation. Plug those in and see which one of them give you the remainder of 0. If it gives you a remainder of 0, we're going to say it is a factor. And if it doesn't give you a remainder of 0, we are going to say it is not a factor. When you plug in negative 1 in this first one, you get negative 4 as your remainder. So that means since you got negative 1 or negative 4 as a remainder, it means this is not a factor of the polynomial. It means it does not go into it evenly, so it's not a factor. Now, negative 3 to the third power is negative 27 plus 4 times negative 3 squared. So negative 3 squared is 9 times 4 is 36. So negative 27 plus 36 is 9 plus negative 3 is 6 minus 6 is 0. So we get that remainder of 0. So that remainder of 0 means yes, it is a factor. Okay? And that's what we're looking for. If we get that remainder of 0, then that means that yes, we have a factor. If we get a remainder that's not 0, then we say no, it's not a factor. So these can be as simple as plugging the number in. You have to make sure you plug in the correct number. Many times I see the most common mistake is people will plug in a 3 here and plug in a 1 here. You got to remember that it's the opposite is what you're looking to plug in when you're doing the remainder theorem. Okay? So examples 3 and 4 we're not going into, so you can mark those off. So that's all for this sheet, is going into the remainder and factor theorem. So these are the only 2 things you had to know. It's all that we're doing for this sheet. So we are going to stop there, and then we're going to go to our remainder and factor theorem worksheet.